Hello, let's see how the 11th challenge from Flare on 2019 could be solved. The challenge was called VV Max. And yeah, let's start with the description of the challenge. So I guess I have it somewhere here. So we got, hey, at least it's not sublec, which didn't tell me much. And we have this exe file with it. So we'll start with loading it to ghidra. I already have the analysis done, so I'll just briefly mention what I did. Okay, let's just go to the main function. So if we go through the main function, we could actually see there was some checking for the CPU type. Your processor OS is too old. And we also could see, well, after the analysis, that this is some kind of a virtual machine. And we can have a function like initialize VM and execute, which actually execute some code inside this virtual machine. And in here, there's not that much cleaned up, but if we go into initialize VM, we can actually see a bit more clear picture because I have my custom type VM, which I defined in ghidra, and I will show you in a moment how does this type look like. But with this type, we can see it actually, the code looks quite nice. Here we see in the initialize VM, we assign the function that this VM supports, which is like 0, multiplication plus addition, multiplication plus addition, with different size of operands, XOR or AND. So basically, all those operations our virtual machine supports. And yeah, so let's see how this VM type looks like. So we can filter here in the data type manager, and maybe VM was not the best name, but this VM, at least what I could find by looking at this assembly, is something like that. So we have this memory at offset 0, which is like 2K. Then we have registers, which is 1K, which is, each register, we have 32 registers. And then we have those like also PC, so program counter. I guess it could be included in the registers. And then we have the functions, definition of the function. So we have like 0 function, multiplication, as I said, those functions could be identified in the binary. I think not all of them were used in the challenge, but nonetheless they were defined. Most of them were used, at least. And if we could look at one of those functions, let's go into the XOR. Also, it can be seen here that this AVX extension is used. So it's not like a simple XOR operation. Will work with the vectorized data. So we'll work with the vector of values, not just simple values. And here again, it's also very nice. We can see if we have the types defined, we can see, okay, the program counter is incremented. We get the destination register from the memory based on the program counter. Again, we increment, then we get another one, which will be, I guess, might be a source, and so on and so on. And it simplifies analysis, greatly. So it's really nice if we can come up with concrete types during our analysis. Then the code looks quite nice, and we can see, okay, we load some data, we do the operation with this AVX extension, and then we store with the destination register the value that we get. So that's like one of the functions. And we can also look at if we go back to the main procedure, we saw the initialize VM. There's also execute, which actually execute code on this VM. So we have a while loop. Whenever in the memory of this VM we didn't encounter FF, then we'll just execute another operation with the with passing the VM to those methods. So each method takes a VM as a argument and yeah, do the operation it's supposed to do. So this is how it looks in the ghidra. Let's see how it looks in the x36 debug. So I have it loaded here. VVMax, we can go to CPU, it's loaded, we can go to user code, and I think I have a breakpoint already in the place. So okay, this is some part of the code. Let's see if there is anything. So actually I think this is almost the execute method, and I think here is the code that will just dispatch the correct function based on the input arguments. And if we go into this function, we'll land in the init, which, or actually it's a 0 function. So as the first function, we will initialize all the registers, the virtual machine registers, to 0. And yeah, we'll then get to another byte of the code that we are executing in our VM. So maybe let's see where is this code, and if we go back here, so I think the code is somewhere here. So if we go to this address, if we follow it in dump, so this is the code. So basically here we have like 0, I think it's the byte for the zeroing. Then we have 11, which is store the value in register index that follow it, and the value is here, and so on and so on. So basically we have some code that's being generated. Oh, actually the code is already there. We just input 2 arguments to the code. So one is this Flare 2019, which we found out during the analysis of the dead listing, and the other one is actually this 32 long string that is a second argument that we need to pass to this binary. And if we check this change command line, I already have it here. So Flare 2019 is easy, but the problem is that we need to find out this 32 character string. And this, so what actually I did, so first I extracted this program. So extracted those bytes and converted them to some readable form. And maybe that was, yeah, maybe not the best idea, because then later I used the textual form to produce some other code, but nonetheless. So let's see. So I think that's the code. So this is the code that converts binary to some readable form. And I have, just like in the simplest form, I have a dictionary that actually maps bytes to some function. So 0 will be init with 0, 1 would be mul add, and we could see this 11 would be this init register. So basically it's initialize our registers with a value that we saw. And there are some more instructions. So each one has a specific function. And what the function does is actually outputs some string form. So like sub b will write, okay, we are subtracting from register 1 to register 2, and we are assigning to this another register. And so basically just the same code as we saw in the binary, but yeah, I'm producing a textual form. And what I'm getting is actually this file, which is, yeah, textual form of what's going on in this virtual machine. So we are assigning some values, register 0, 1, 3, 4, 5, 6, and so on and so on. Maybe let me just not word wrap for a moment. So we are assigning some values. We do some operation now. There's like permutation, bit shifting, and XORing. And remember, this is not regular operation. There's not like a byte or word or double word operation. This is like those AVX operation which operate on multiple bytes at the same time. So they are a bit more complex to analyze. At least it was more complex for me. So as we can see, the code is quite long. So I honestly didn't have idea how to approach it to reverse engineer it. So what I come up with was probably the craziest idea. I thought I will try to write a Z3 solver that will solve me this equation, because basically I saw it as an equation that has to be solved. So I have some input, and those inputs, some of them are constant, some of them are provided by the user. I think this R2, which we don't see here, is provided by the user. This is probably Flare 2019 string, maybe somewhere here duplicated. So we have an input and we expect some output. I think output is compared with those bytes, but nonetheless there is some output we expect. So I thought, okay, I will write a Z3 equation and I will ask Z3 to solve me this really complex equation. And I guess the inspiration was from Life Overflow. I think he also did something similar for solving one of the Pony Island challenges. Just the problem was that, I probably don't want to do that manually. And the other problem was that at least I don't know if Z3 can support those AVX operations on multiple data. So what I did, I actually implemented my own AVX operation using Z3. And I think, let me see which one is the correct. I think this solve2 is correct one. So so what I did, again, this is a bit silly because I first converted binary data to this textual form, and then based on the textual form, I actually generated this Z3 equation. So I created 32 registers, like bit vectors, which is 32 bytes, which 32 times 8 in length. And then, okay, we have some array, but that doesn't really matter. And we have all those operations that we saw in the virtual machine converted to some Z3 operations. So it's like a simplify, if, extract. We extract something from the registers and we generate some part, at least, of the equation, and we return it. And then the other operation will take that and do some other modifications based on that bit vectors, and it will return something else. And so on and so on. You can see I have a lot of comments here that basically I try to understand how those operation works, from which side they take the data, because like if we have like a 32 bytes, we can either go from left or right. Some operation are, I think they operate on like 4 bytes in one go. Some of them operate on specific bytes. So it was quite tricky, at least for me, to come up with the correct Z3 code that will do what I want to do. Some of them are quite easy because we have like a VP XOR. It will be a simple XOR operation and or. So only those tricky operation from AVX, maybe it was a bit more difficult to implement here. But so this is what I come up with. Some parts of this code are really not pretty. I would even say ugly. Like here, there's like a bunch of ifs, Z3 ifs that actually I go by index one by one and extract correct data. But yeah, I didn't know if I can do it better. Let's see if there's anything interesting here. I guess there's like a lot of simplify to get something easier from this code. And yeah, the main program is just like, as I said, I should have used binary file, but I used like this textual file and parse it with regular expression. So I also had to deal with issues with regular expression, but nonetheless, it wasn't that difficult with the regular expressions. It was like just extract some index, register index value and operation, and basically just call correct method. but also a lot of codes here to yeah, debug my code. So having this solved too, we could actually try to see if this huge equation that Z3 will generate us is actually solvable, because that was the idea. The problem is not to write the equation. The problem is whether it is solvable by Z3. And let's see. So let's just solve to pi, and yeah, I will pass this. So cc3 is this file which is having the generated textual form of the program. And okay, it's not solve, it's solve, of course. Okay, I'm not in the correct folder. Python 3 solve, okay. So yeah, I'm just have some opening file. And yeah, so basically we got a very huge Z3 equation, which is actually not even printed in the whole form. There is a lot of like, maybe not a lot, but there are some like triple dots, which says, okay, there's more, but I will not show you because it's too big. And actually at the end, we could see it is solvable. So it wrote sat. And we got that R1 is this value. So now we'll just take this value and, okay, what's actual value that we need? Because this is like decimal, and I guess we would like some bytes. Or maybe like characters. So let's just use the hex function to convert it to hex. Okay, yeah, string should not be interpreted as integer. So we have the value, and we can see there's like a in the ASCII range. So we might be on a good track. So now what we need bytes from hex, and we get to pass this value, and now we need to give it as a string, and yeah, we got some string. Okay, at least the characters are printable. That's good, because I think I added the to my Z3 solver, I added specific requirements that the characters has to be printable. But yeah, so we got this value, and so let's just see if we pass this to our VV max, and first would be Flare 2019, and the other one would be this string, we'll get something. And yes, we got the flag. So AVX2 VM makes base 64 complicated, add Flare on COM. And actually, yeah, basically it's really complex base 64. So I went through all this trouble of generating Z3 solver for this equation to actually solve base 64. Yeah, so maybe that was a bit too much, but nonetheless, I was really happy I was able to solve this with Z3 and yeah, solve this challenge. It was quite fun. I learned a lot. So yeah, that's all for the 11th challenge, and for me that was the last one from 2019. I hope you like this, and if you did, please like and subscribe, and yeah, that's all. Thanks.